In this video, we will explore directory structures in operating systems. Directory structures are the way that operating systems organize files for efficient storage and retrieval. We will cover single-level, two-level, and tree-structured directories. Let us start with the single-level directory structure. A single-level directory contains all files in the same directory, meaning there is only one directory in the entire file system. All files in this directory must have unique names to avoid conflicts. This structure is simple to implement but very limited in organization. Because of this limitation, it is suitable only for small systems with few files. Here's an illustration of a single-level directory. It has a root directory, under which all the files are placed. The single-level directory has significant limitations. First, naming conflicts between users can occur if multiple users try to create files with the same name. Second, there is no logical grouping of files, which makes it hard to organize them. Third, the organization is poor as the number of files grows, making it difficult to manage large file systems. Fourth, it is difficult to search for specific files as everything is in one big list. Imagine a file naming conflict scenario. We have user A and user B who both want to create a file called project.txt. Since there is only one directory, the system will not allow both users to have a file with the same name, leading to a conflict. To prevent this, users must coordinate file naming conventions, which can be quite a headache. Now let's discuss the two-level directory structure. This structure creates a separate directory for each user. There is a master file directory, or MFD, which tracks all the user directories. Each user file directory, or UFD, contains only that user's files. This approach eliminates name conflicts between users because each user has their own directory. This also leads to better search efficiency and improved file organization compared to a single-level directory. Here's an illustration of a two-level directory structure. The master file directory points to each of the user file directories. Each user has their own directory containing their files. The two-level directory also has several key limitations. First, there is no grouping of a user's files by type or project. Second, this is limited to only two levels of organization. Third, it is difficult to share files between users because files are isolated within user directories. Fourth, it is inefficient for complex projects with many files, as all the files are in one place. In a two-level directory, the file path structure is simple: /username/file name. For example, /user_/project.txt would access project.txt in user A's directory. However, there is no direct path to shared files. You must copy files between user directories, and there is no way to organize files by project or type. All files in a user directory are at the same level. Let's explore the tree-structured directory. This is a hierarchical organization of directories and files, which allows directories to contain both files and subdirectories. This provides a natural way to organize files by categories and projects. This has benefits such as efficient file organization, logical grouping by projects, and easier navigation and search. It also supports file sharing and allows for unlimited depth of organization. Here's an illustration of a tree structure. At the root there can be multiple directories like home, bin, and etc. The home directory can contain directories for users, and each user directory can contain subdirectories and files. In the tree-structured directory, we can specify file paths in two ways: absolute and relative. An absolute path is the complete path from the root directory. For example, /home/user1/docs/report.doc. An absolute path always starts with the root, which is /. A relative path is relative to the current directory. For example, docs/report.doc assumes your current location is the home/user1 directory. You can also use double dots, or ... to navigate to the parent directory. For example, /user2/projects will navigate to the projects directory inside the user2 directory. There are also a few common directory operations in the tree-structured directory. To create a directory, you can use the command make directory followed by the directory name. To delete a directory, you can use the command remove directory followed by the directory name. To list directory contents, use the command list followed by the path. To change directories, use the command change directory followed by the path. File sharing is a key feature in tree-structured directories. Multiple users can access the same files and directories, and access control lists, or ACLs, define permissions for each user. Shared directories can be mounted in multiple locations, and different users can have different views of the file system. Protection mechanisms prevent unauthorized access. There are also granular permissions such as read, write, execute, and delete. Here's an example of an access control list, or ACL. These specify which users have what permissions for each file or directory. For example, the file /home/shared/project.doc has read, write, and delete permissions for user 1, but user 3 only has read permission. Let's compare the directory structures. Single-level directories have very poor organization. File names must be unique system-wide, and search efficiency is only medium on small systems. File sharing is not supported and scalability is very poor. Implementation complexity is simple, but single-level directories are rarely used today. Two-level directories have limited organization, and file names must be unique per user. Search efficiency is medium, file sharing is limited, and scalability is poor. The implementation complexity is moderate, and this is of limited use today. Tree-structured directories have excellent organization. File names must be unique per directory, and search efficiency is high. File sharing is well supported and scalability is excellent. The path specification is complex and the implementation is complex, but it is widely used in modern operating systems. To summarize, single-level directories are simple but limited to small systems. Two-level directories separate user files but lack deeper organization. Tree-structured directories provide flexible hierarchical organization. Directory structure affects file search efficiency and organization. File sharing capabilities depend on directory structure, and access control is essential for multi-user environments. Real-world applications include: the Windows file system uses tree-structured directories with drive letters. Linux and Unix use hierarchical structure with a single root. Cloud storage like Google Drive and Dropbox uses tree structures with sharing capabilities. Mobile operating systems like iOS and Android use hierarchical file systems. Tree-structured directories have become the standard for modern operating systems due to their flexibility and organizational capabilities. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.